Okay. So the problem is given that an 8 mm thick saturated clay layer, okay, which lies beneath the permeable dense sand layer, which lies above, not below, which lies above the permeable dense sand layer. The clay settles by 40 mm in 2 years when subjected to a widespread load of 50 km square at its surface. What will be the ultimate settlement of the clay? Okay, calculate means you have to find what is the ultimate settlement of the clay, means you have to find the capital delta H. Okay, what will the ultimate settlement of the clay? Calculate the compression index Cc of the clay. Assume the water able to is below the dense sand layer and will not influence the settlement properties of clay. Average bulk unit weight is given as 18 kg per meter cube. Coefficient of consolidation, that is CV, is given as 1 meter square per year. Specific gravity of the soil is given as 2.65. Unit weight is equivalent to 9.81 kg per meter cube. Okay. Now we have to find what? We have to calculate the CC. CC is nothing but the compression index. Okay, compression index. Okay, so before going for the compression index, we should know from where the compression index first comes along. Okay. So as you can see, it's a it's a dimensionless parameter that measure how compressible the soil. It is calculated by finding the slope of the curve between the void ratio and effective stress. Void ratio is plotted on normal scale, whereas the effective stress is plotted in a logarithmic scale. So in actual fact, in the graph, when a particular clay soil is subjected to compressive force, or which is subjected to pressure under compression, the void ratio decreases as the pressure or stress increases. See, so if this is y-axis is void ratio and the horizontal axis is stress, so void ratio decreases in a concave way. Okay, in a parabolic, in a concave way. This way it reduces. So if this is the initial stress E1, this is initial stress, sorry, this is the initial void ratio E1, this is, that will be the its corresponding initial stress sigma 1. Similarly, the void ratio decreases as the stress increases. The stress void ratio will be E2 and the stress will be sigma 2. Okay, so the coefficient of compressibility, okay, coefficient of compressibility compressibility that is A suffix V is given as equal to E2 minus E1, or sorry, E1 minus E2 divided by sigma 2 minus sigma 1. Okay. Okay. So this directly you can calculate from the curve if the curve is in a concave shape or a original curve is formed in this way. Okay. The settlement, the effective stress and the void ratio varies in this way. Okay. But if we convert this particular curve in a particular straight line, in a particular like this straight line, for ease of calculation, if we convert this curve in a straight line, then again here is the effective stress on horizontal axis and void ratio on the y-axis. Okay, so this horizontal scale becomes the logarithmic scale. Okay, the horizontal scale becomes a logarithmic scale. This can be considered as a log of sigma. See, so as AV is nothing but the slope of this curve when the actual curve. Similarly, CC, that is compression index, CC is nothing but compression index is a slope of the logarithmic scale, and it can be written as delta E by log of sigma 2 by sigma 1. It can be written this way. So compression index, so compression index CC is nothing but E1 minus E2 divided by log of sigma 2 by sigma 1, and log of sigma 2 by sigma 1 is nothing but log of sigma 1 plus delta sigma, that is increase in stress, divided by sigma 1. You can write this way also. Okay, so this is the compression index. Earlier we also studied there is what coefficient of compression also. Coefficient of compression, it is written as CV, and for CV you need to find the time factor. Time factor is given as TV is nothing but CVT by d square, and also TV is equal to pi by 4 U percentage by 100 whole square if U percentage is less than 60%, and U is what? Degree of consolidation, is nothing but degree of consolidation. So you have to know all this thing. Okay, so coefficient of compressibility is nothing but slope of the actual curve of the actual stress versus void ratio curve, whereas compression index CC is the slope of the straight line of void ratio versus logarithmic of effective stress. So that's, we have to know that thing. Okay, so we have to know that thing. Okay, so all these things that we can use to find the compression index of our given problem. So this is our given problem is here. See, so an 8 mm thick saturated clay layer is given, and it has a certain widespread load of this much is given, everything. Okay, so we will find one by one thing how to calculate the stuff. Okay, so we will go down now. So here, okay, now we will find what we have to do. So the problem it is given that there is a clay layer of having 8 mm thick. Okay, so I will just bring the problem here also. Okay, I will copy it here. So this is the problem. Okay, so we will now look at the problem. So it says that a 8 meter thick saturated clay layer lies above a permeable dense sand. Okay, so it is written as, suppose this is a clay layer and this is a permeable dense sand, means water can pass through this sand layer also. This is the bottom, there is a sand layer, and this is what a clay layer is there. Okay, and on this clay layer the total stress of 50 kilonewton per meter square is acting on the surface, and for the time frame of, and this thickness is of 8 meter. Okay, it is given that, and again what's we have given that in a time t of 2 years, okay, in time the clay settled, that is small delta h is of 40 mm. Okay, 40 mm. Okay, so from this we have to find what its degree of, we first need to find what is the degree of consolidation. Okay, consolidation. what is degree of consolidation? Percentage degree. Okay, percentage degree can be found by two ways. If you just go up, if we just go up and we can see, okay, so u can be, that is the u, that is the degree of consolidation. Okay, this is the variation of degree of consolidation with respect to time. On the horizontal axis there is a time factor, and the vertical axis there is a average degree of consolidation. Okay, so u, that is degree of consolidation, percentage degree of, can also be written as equal to settlement at any time t, settlement at any time t divided by into 100 divided by ultimate primary consolidated settlement of the layer. Ultimate primary consolidation settlement of the layer. Okay, so u percentage is nothing but delta small h by delta capital H. Okay, so we have to find this thing. Okay, so where h, small h, is for any given time t, and this ultimate primary concentration of the whole layer, it can be found out this way. Okay, or you can also find by using pore water pressure. Okay, so u, that is u percentage, that is degree of concentration, can be also written as excess pore water pressure dissipated by initial excess pore water pressure. Okay, means you can also say that if u0 is the initial pore water pressure minus pore water pressure at depth z after a certain time t, okay, after a certain time, when and divided by initial pore water pressure into 100, we do that. We can also get, by using this thing also, we can get the degree of consolidation, because since in consolidation the soil is saturated soil, 100% saturated soil is considered, 100% saturated clay is considered, and consolidation occurs when the pressure is applied on the soil, saturated soil, and from its voids the water gets dissipated. Okay, so if it is 100% saturated soil, it will have certain pore water pressure, initial pore water pressure u0 obviously, and as the pressure increases on the soil, the pore water pressure gets dissipated, or it comes out from the soil. Okay, so how much pore water pressure dissipated in a given time period of t, years, days, months, what it may be, from that we can find the degree of consolidation. Okay, degree of consolidation. So there are two ways of finding degree of consolidation, that is by u0 minus u after a certain time t by u0 into 100. You can also write there. Also you can find by at a given time what was the settlement consolidation by total consolidation into 100. Okay, so this way we can find different terms, we can find the degree of consolidation. Okay, so in this problem the clay settles by 40 mm in 2 years. Okay, so in 2 years it settles by 40 mm. Okay, so what we can find is time factor. TV can be written as pi by 4 u by 100 square, u percentage by 100 square. Okay, you can find this thing. Okay, that is nothing but CVT by d square. Now again there is one thing, we have to know how the percolation is happening in one way only or two way only. Since the clay layer, above clay layer there is nothing, means only air, atmospheric air is present, and below the clay layer there is permeable sand. The problem defines it is a permeable sand, permeable then sand is there. So we can say that the water passes through the clay layer or percolates from the clay to clay layer in two ways, in upward direction also from the center and in downward direction also. So in this case we can consider d, that is the distance, the maximum water, this maximum distance the water particle has to travel before getting percolated out from the soil is can be written as h by 2, that it can be taken as 8 by 2 meters, that is 4 meters. Okay, that can be considered as 4 meters. Okay, okay, okay. So in this case we can write pi by 4 is equal to, now let's consider that u. Okay, so that u, just we have seen that it can be written as delta h at a given time t, at a given time t, divided by total capital delta, that is total that is total settlement or total consolidation. So we can write that pi by 4 multiplied by delta h by time certain time t by total delta h whole square, okay, is equal to nothing but cvt by d square, is nothing but cvt by d square. Okay, so we can write it as pi by 4. So in problem how much settlement has occurred, that is of 40 mm settlement has occurred for 2 years. See, so we can write is here 40, and what is total settlement, it's not given, we have to find that using this formula, that is total settlement delta h whole square will be equal to, now what is this cv, this cv is nothing but coefficient of consolidation. So is in the problem coefficient of consolidation is given, yes it is given as 1 meter square per year. Okay, so we can write as 1 meter square per year, and how much time it required to get a consolidation of 40 mm, that is time t is given as 2 years. So we can directly write 2 years, this is in meter square per year and this is year, so we don't have to convert any signs. So divided by d square, so and how much d we have found, that is 4, that is 4 square. Okay, so from this we can find delta h as equal to 100.265 mm square, we can find okay, so this way we found the delta h. Okay, that is total total consolidation of the soil. Okay, how much total consolidation of the soil will takes place. Okay, so now we have to find, compression index cc. Okay, we have to find the compression index cc. So using delta h, how we can find the compression index, what is the parameter of finding the compression index? Okay, so compression index can also be found by the formula of delta h, that is total consolidation can be written as delta h into original height, that is h0, that multiplied by compression index cc by 1 plus e0 into log of sigma 0 plus delta sigma bar, obviously by sigma 0 bar. Okay, see where sigma 0, where is sigma 0 bar is nothing but stress at the center of clay layer, stress at center, stress at center of clay layer, stress at center of clay layer. It is given as that one. Okay. Okay, so from here, so CC can compression index is written as that it is written as E0 minus EF by log of sigma 0 bar plus delta sigma bar by sigma 0 bar. Okay. Okay, so change in void ratio. So you, by using this thing also we can find, but we don't know the exactly what is the final void ratio. We don't know, so hence we cannot use this particular formula. So we will have to use this thing, that is delta H by H0 is nothing but equal to Cc by, that is compression index, by 1 plus E0 log of sigma 0 effective stress initial plus change in effective stress by initial effective stress. Okay, so we have to use this particular relation to find what is compression index. So in this case, sigma 0 is nothing but stress at center of clay layer. Okay, and we also need to find what is the void ratio, what is the initial void ratio. Okay, now what is delta sigma in this case? What is delta sigma bar in this case? What is delta sigma bar? So delta sigma bar is nothing but is given in the problem, that is the when subjected to widespread load of 50 kN per square, there is change in effective stress. Change in this effective stress is given as 50 Newton per meter square. Delta sigma bar is nothing but 50 kilonewton per meter square. It is given as that thing. Okay, when subjected to widespread load of 50 kilonewton per meter square. Now the soil is of, if this is the sand and this is clay layer of what, 8 meter, and above 8 change, earlier the stress was not there, hence the stress was 0. Now the stress is what, change in stress is what, delta sigma is gains by 50 Newton per 50 kilonewton per meter square. Okay, so for that the stress increases in an 45-degree angle. Okay, so here at center, means at 4 meter height, what will be the stress? Okay, so that will be what, so here the soil is fully saturated, hence it will be a gamma sat, will be the unit weight of the soil. So stress sigma 0, initial stress before this particular 50 kN load, 50 kN per meter square stress was acting, the total effective stress or initial effective stress just at the center of the clay layer, just due to the weight of the soil, will be equal to what, unit weight of soil gamma sat into height at the center, that is 4. Okay, so now we have to find the gamma sat. Okay, gamma sat, we have to find the gamma sat. For that we should know the unit weight formula. Unit weight gamma is given as G plus E into specific gravity. Okay, G into ES plus 1 plus E into gamma W So if the degree of saturation here SR, if it is ESR, it is written as ESR is equal to 1, since the soil is fully saturated. So gamma sat becomes equal to G plus E by 1 plus E into gamma W. It becomes this way. Okay, G plus E well, if the soil is dry, then if the soil, then SR becomes 0. If dry soil, if there is a dry soil, then degree of saturation becomes 0. So gamma dry become G by 1 plus E into gamma W. That's the full way we find out. Okay, so now since the soil is saturated and we have unit weight of soil, okay, so unit weight of the soil is given as gamma bulk, that is 18 kilonewton per meter cube. It is given as 18 kilonewton per meter cube. So we can find the void ratio, initial void ratio. What was the initial void ratio? So gamma saturated is nothing but what? It is given as gamma bulk, that is 18 kilonewton per meter cube, is nothing but equal to G. How much specific gravity is given? How much specific gravity is given? That is given as 2.65. Okay, so we can consider, so this is 2.65. What is void ratio? Void ratio is not given, that's why we are doing this thing. We need to find the void ratio. Plus E by 1 plus E into unit weight of water is given as 9.81 kilonewton per meter cube. Okay, from this we can find the void ratio, initial void ratio E0 before the stress acted is given as 0.976. It comes out to be 0.976. Okay, so and also the gamma sat, from this we can find, for using gamma sat we can also find the initial stress, initial effective stress sigma 0 bar can be written as gamma sat into 4, that is 18 into 4, that is 72 kilonewton per meter cube. This is its effective stress. By using all this thing, that is these two things we have found, that is initial void ratio and initial effective stress, we can find the total settlement delta H. No, we already know total settlement delta H. We can find the compression delta H by H is nothing but compression index, that is Cc by 1 plus E0 into log of 10 sigma 0 plus delta sigma by sigma 0 bar. So delta sigma, that is total consolidation, we earlier found out delta H, total consolidation delta H, that is 100.265, 100 so this is 100.265. total height is what? 8 meters, that is 8000 mm. Compression index Cc we need to find out 1 plus E0, that is initial void ratio was 0.976, 0.976 multiplied by log of 10. Initial effective stress is given as 72 kilonewton per meter cube plus change in stress delta sigma bar, that is stress at the center of the clay. No, sorry, not that. Stress at the center of the clay was sigma 0 bar. Delta sigma bar is what is the stress acting on the soil, whatever the external load, external pressure which acts on the soil, which is given in the problem, that is 50 kilonewton per meter square, that is 50 kilonewton per meter square divided by 72. So our compression index Cc comes out to be 0.129, and there our problems finishes. Okay, that's it. Thank you for watching. We will meet the next class.